Alright students, this video is going to go over section 2.2 in Math 3. In fact, we're going to go through more than that. What it is in 2.1 we talked about the parent functions, the absolute value function, the quadratic function, the linear function. This section seems to be talking just about linear, but it applies to all of the functions. That's the whole reason we talk about parent functions. So right away, let's focus on what's easy and what's not easy. The notation is very, very tough. But what's actually geometrically happening is not too bad. We're shifting the black lines entirely shifted to the left or entirely shifted to the right. We can entirely shift it up or you can entirely shift it down. So now by moving a graph left to right, up or down, you can put it anywhere on the screen that you want. That's one way we can translate it. But we can do more transformations than just that. If you look over here, this will be shared with you in class, and this actually has all the transformations. So how do you keep all this stuff straight? Well, a couple things is, it's not as bad as it looks. These two are both vertical. These two are both horizontal. So it's not like there's really 4 rules. There's really 2 rules. One's positive, one's negative. Basically, one amounts to left and right, or up and down. And that's what it is. And this will be easier to see when we switch to Desmos. These two are reflections, so it's not like 2 rules, it's just 2 different types of reflections, because you can go reflect across the x-axis or reflect across the y-axis. And the notation's again about the same. There's a negative, but the difference is where do you place it. Okay. Same thing here. The vertical stretch and the horizontal stretch. It's all about where did you put that multiplier. Did you put it in front of the f of x or did you put it inside the f of x? So let's go ahead and switch over to Desmos and just run through those real quickly. Here in Desmos, I put my parent function, x squared. You could also start with the parent function, absolute value. Okay. The point is, all the shifts we're going to do will affect them all the same. Left and right for this one would affect left and right for this one. Okay. The notation would be exactly the same. Alright, so here's our graph. Here's what I'm going to do. I'm going to create a new function called g of x. That way I can leave my parent function here and say g of x. And I'm going to start using the textbook notation. F of x plus 4. Whoops. I will use their notation. I apologize. There we go. F of x plus 4. The other thing that's kind of confusing, if they're both red, let me go ahead and click over here. And I'm going to change the color. There we go. That's better. Now I can see the original one. Now I can see the new function. The parent function. And you can call that the child function if you want, whatever. But basically, that one has now been moved up by 4. That point has now been moved up by 4. And so has every other point been moved up by 4. That is what we call a vertical translation. Okay. Now, the nice thing about this is if you said, oh, shoot, you know what, I'm sorry, I meant negative 4. So I meant to subtract 4. Well, when you subtract 4, the entire graph shifts now in the other direction. 0 now became negative 4. So take a look at that and think about when x was 0, it used to be 0, 0, right at the origin. That's why I like this as a parent function. But by subtracting 4 from all your points, the old 0 is now negative 4. Okay, so this is a vertical shift up or down. Alrighty. Next, let's get into horizontal shifts. Horizontal shifts. Take a look here. I'm going to go minus 4 here, and wait a minute. Take a look at that. We went from 0, and I ended up at a positive 4, but that's something seems weird here because we typed in minus 4. Let's see what's happening here. So, we have a shift in the positive direction to positive 4, even though we put x minus 4. Alright, so here's how you got to think about this. In your original function f of x, it went through 0, 0. Well, let me ask you this. What would be the new 0? Okay, and that's what's tricky here. I know you're subtracting 4, but you got to ask yourself, what would make it 0? And that would be positive 4. Okay, see if you agree with that. If you went positive 4 and plugged it in, that would give you 0. So I know it's tricky. You just got to practice with it and get used to it. Find some way that helps you memorize it. Remember, that one's the opposite direction. All right. And if you don't believe that, let me show you. Clear all this stuff up. If you change it to positive 4, it shifts it over here to the negative 4. And don't worry, when I'm doing that myself, I'll have times when I forget that. My brain thinks I want to shift it to the left. I know that should be the backwards, but then, you type in plus, it will go to the negative. Type in minus, it will go to the positive. So try and get used to that. Those are the horizontal shifts. Okay. And one other nice feature here, let me go ahead and do it right now. If you put a H right there, I like H for horizontal, and H happens to be what they use in the book, you can then see that it shifts it left or right. Okay, if you add a slider here, you can then shift left and right. That's what I love about Desmos, these little features. All right, let's take that out. Okay, let's do 2 other ones. Okay, take a look at this, and here's what we're going to do. We're going to do a negative in front of F, and whoa, it flips the entire graph upside down. Now take a look at that. That might make natural sense to you, but if it doesn't make sense to you, why is it upside down? Take a look at here. Nope. There we go. If we add a table, no, I want my table down here. I'm a little picky. Okay, if we add a table here, you can go 0, 1, 2, 3, 4, 5, and you say, wait, why didn't it fill in the table? Well, instead of f of x, instead of y1, we want to put f of x. And instead of f of x, we want to put f of x1. So it uses our x1s from our table. And bam, there it goes. It filled in your table, and here's our points. So what did g of x do? Well, g of x1, take a look. Because g had a negative, all it did is it just took our y values and turned them all negative, 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 negative. All right. And there you go. Okay, so a negative in front turns everything negative. That means it's on the upside down. And now you know how to do a reflection. And that's very, very, very useful. All right. Let's do one more thing with this one before we close it out. What we're going to do is we're going to modify our table. And in fact, I think we might need to just start over with that. Let's get rid of that. What we're going to do is we're going to put in the negative here. And you say, wait a minute. When you put the negative inside, nothing changed. Well, that's exactly right. Nothing did change here. What's happening is this is a y-axis reflection. And when you do a y-axis reflection, it's weird, but it does this. All your points, your point 1, 1 here, would go to the other side. But there's already a point here. So you reflect it across the y-axis. Oops. The y-axis. But every point here, because it had y-axis symmetry, every point had an identical point on the other side. So you don't really notice it. So let's do this. Let's modify our original function, and that's what's nice about it. Okay. Take a look at this. This is going to, what it's going to do essentially is what used to happen at the negative will now happen at the positive. What used to happen at the positive will now happen at the negative. Okay. So let's modify our original equation. Let's give it both a horizontal shift and a vertical shift. Let's give a vertical shift of 3 and a horizontal shift of -1. Okay. And now there is a reflection here. 1, 3 became -1, 3. And you can sort of see that there. Okay. So when it used to be positive, this one now has the reverse. The negative is now the positive is now the negative. I know it's kind of weird to see, but again, now let's put our table back in and change this to f of x1, g of x1, and let's do this. Let's go with a couple negatives, -3, -2, -1, 0, 1, 2, 3. Now pause for a second and look at that video. Oh, sorry, look at that table. Pause the video and look at that table and see what changes. See what's inverted. So again, it's a little bit tricky to see, but what used to be at -3 used to be 19. Now +3 gives you the 19 for the g function. Okay, so It's a little bit tricky to look at both tables at once, so what can also help, let's get rid of this, you can make another table separate. Let's get rid of this table. Now I'll add another table down here, and this one will just be G. But notice now my second table has G2, so I gotta go, sorry, X2, so I have to go, so take a look. -3 used to give you 19, now it's +3 that gives you 19. That might be easier to see this. -2 used to give you 12, +2 now gives you 12. Let's see, let's change. -1 used to give you 7, +1 now gives you 7. So it's changed everything. And again, it's a little bit tricky. The more you play around with it, and the sooner you have this sort of figured out that it's a y-axis reflection, it gets a little bit easier. All right, we've got a couple last ones to do, and let's wrap this up. Let's get rid of all this. And let's go back to our original parent function, x squared. Okay. And okay. So now what we're going to do is we're going to put a multiplier. This one's actually something you've seen all the way back in Math 1. We called it slope when we were talking about straight lines, and it's sort of the same here, except for it's a constantly changing slope. But you're changing you're changing how fast this thing increases. Okay. And now what I can do here is I can put 3f of x, and that's steeper. And you can do 4f of x, and that'd be steeper. Okay. Now in terms of the table, again, if this is f of x1, and we go 1, 2, 3, 4 here, 5, then for our next one, if we did 4f of x1, notice it's 4 times everything. That's all it is. A 4 multiplier is one of the more easy ones to see because it just takes all your y values and multiplies them by 4. Graphically, what that does is it makes it look like the graph is much steeper. It looks like the sides of it are increasing much faster. All right. So play around with that. Now, if a big number makes it steeper, then how do we make it less steep? Well, if 4 makes it really steep, let's say 1/4 f of x, and there you go. And notice, by doing f of x, I don't have to retype it. Here's my original. I don't have to type x squared over and over again. Okay. I didn't have to name them all G, but later on, it would help to have different names for these. G, H, K, L, whatever you want. Okay. But what you can do now, the whole point of this is now you can match almost any graph. Okay. And if we import our graph from our warm-up today, we'll wrap this whole thing up. All right, so what we're going to do is I'm going to go up here, I'm going to get a new blank graph, and I'm going to insert an image. Yeah, you can do any image, and this is an image of a solar graph. I'm going to take the x and y axis. No, I want the x and y axis. I don't want the grid. That's what I want. All right, now we're going to resize this so it goes over here. And the general thing here is, oops, it's going to take some time. All right, now I didn't position my picture perfectly, but we'll get it done. Let's say f of x equals x squared. Okay, so there's a parabola. I'm going to turn it off now for a second because we don't want to see it. G of x, our graph, we'll call it G for our graph. We want to match this. I'm going to say g of x equals negative f of x. And it didn't like my capital X there. Sorry, but there we go. Okay, now you notice I'm sort of matching it, but I need to shift it over. Now we've got to shift it over a couple units. If this was 10, this would be about 5. Let's say about 4.5. I'm going to give it a 4.5 shift. And again, minus 4.5. 4.5. There we go. Now shift it almost right. I might shift it over again a little bit. And I want to shift it up a little bit. So again, a vertical shift, we add a number at the end. We're putting together everything we know. And again, if this is my y-axis of 10, ignore these numbers. I didn't scale it properly, but just to do this for now. If this was 10, this would be about 8, let's say. So let's go about plus 7. And now we're getting pretty close. So let's do this. Let's change that to 3.5. Change this to an 8, and we're almost right on the money. Last thing we want to do is I want to widen it just a little bit, see if we can hit that a little bit better. And again, to widen it, that's a multiplier in front. Again, skinny is a number bigger than 1, wider is a number less than 1, and we're not using, we're playing guess and check here a little bit. Looks pretty good. I'm going to go 0.5 would be a little wider. That's pretty darn good. Okay. Again, we can just still lower it a little bit, but right now let's sort of have the whole data under the curve. I could lower it a little bit, but let's not bother. The key thing here is this is actual real data from real solar panels on a daily output, and what you can see is you can then graph and find the peak. Okay. In calculus, they'll actually try and find out when is the rate increasing the most. Okay. Not when was it the highest, but when was the rate changing the most. So like from here to here we have a change, here to here we have a change, here to here we have a change. But as you go in these hours right here, even if the highest is changing by not as much, whereas we see a bigger change right here. So a lot of concepts that could be happening here, but even just with what we know, we were able to start with just an x squared and shift it with the horizontal shift, vertical shift, and then change the stretch, the opening, the wideness, whatever you want to call it. I call it the width. So this, we made it a little bit wider because it was a 0.5, and there we go. Now we can really model that data pretty well. All right, thanks for watching, everyone.